Hi there, Mr. Sutton here, bringing you the AB Calculus 5-7 Extra Practice number 2 solutions on properties of definite integrals. For this set of problems, we're given the integral of 0 to 3 of f of z dz and also from 0 to 4 of that same function. And for our first task, we're asked for the integral from 3 to 4 of f of z dz. All right, well, if we have the integral of all the area from 0 to 4, and we have the area from just 0 to 3, I can get the area of 3 to 4 by just subtracting these. So let me do integral from 0 to 4 minus integral from 0 to 3. That's going to chop out all the area from 0 to 3 and just leave the area from 3 to 4. So that's just going to be, let's see here, 7 minus 3, which comes out to 4. On this problem, I'm trying to find integral from 4 to 3 of f of t dt. So there's a few things going on here. Recall from part A, we found the integral from 3 to 4 of f of z dz, which we said was 4. Well, this is basically just that integral with the limits of integration reversed. And also we have a different variable of integration, but we've seen that that doesn't actually make a difference. Whether I call this a t or a z, it really ends up doing the same thing mathematically, because this is just a dummy variable in here. All right, so this right here, since it's the reverse limits of integration of this, we basically have the situation of negative integral from 4 to 3, or from 3 to 4 f of z dz. We have the negative version of this integral, which is just going to end up being negative 4. For this problem, we want integral from 0 to 12 of f of t dt. Now, the different variable isn't going to make a difference whether this is a t or a z or an x or whatever. What will make a difference on this one is that we don't have enough information to get all the way from 0 to 12. The farthest we can go is from 0 to 4. It'd be nice if we could just multiply these two integrals together and the 3 and the 4 would give us a 12, but it doesn't work that way. These are areas we're talking about. I know nothing about the area from 4 to 8 of this function. So not enough information, can't do anything else here. For this set of problems, we have some integrals of h of r dr. We have one from -1 to 1 and from -1 to 3. Our first task here is to find the integral from 1 to 3. So this one, we actually have everything we need to get it. We already know the area under h from -1 to 3. It's 7. This is asking about a piece of that area. So we don't want all of the area in this second integral. We just want part of it. Well, to get rid of the part we don't need, we have to subtract the area from -1 to 1, which just happens to be this other integral that they gave us here. So we can rewrite this essentially as integral from -1 to 3 of h of r dr minus the integral that you see up here from -1 to 1. If we subtract the integral from -1 to 1, that's just going to leave us with the area from 1 to 3. So this is going to end up being 7 minus 0, which is just 7. For this part, we want the negative integral from 3 to 1 of h of u du. So there's a few things going on here. First off, recall that the integral from 1 to 3 of h of r dr, and this was in part A, that came out to 7. So we're going to use that to help us here. So one thing going on is we have this change of variables, but the variable of integration is not going to make a difference whether you call this a u or an r. It's a dummy variable anyway. So it doesn't really matter what you call that variable. So instead, we're just going to focus on the limits of integration here. So 3 to 1, that's the upside down version in terms of limits of integration of 1 to 3. So if we didn't have this negative out here, by itself, the integral from 3 to 1 would just be the opposite of this integral right here. So that would end up being -7. But we do have this negative outside. So this really is a -7 that's going on here, which comes out to a +7. On this problem, we're given an integral of f of x from -1 to 1, and also g of x, and a couple values of those. We want the integral from -1 to 1 of 2f of x minus g of x. So using our properties of definite integrals, we can actually split this up and also factor this 2 out of one of the integrals. So I can split this up into 2 times the integral from -1 to 1 of f of x dx minus the integral from -1 to 1 of g of x dx. And let's see, this integral of f of x here, this is just 7. So this first piece is just 2 times 7. This g of x integral is negative 9 by itself, but we're subtracting it. So this is negative 9. So then we have 14 plus 9 giving us 23. And that's choice C. For this problem, we're given a continuous function f such that we have the integral from 0 to 17, 17 to 20, and 13 to 20 of this function. And based off that, we want to find the integral from 0 to 13. The key on this is to realize that really when it comes down to it, we're just playing around with different areas under this curve of f of x. We have an area from 0 to 17, an area from 17 to 20, and also this area from 13 to 20. All we want is the area from 0 to 13. So just putting this together here, I see that if I were to add these two areas together, these first two, I would end up with the area for 0 to 20. And then if I just subtract this area from 13 to 20, I would get what was left over, 0 to 13 area. So that's really what I'm going to do here. Using my properties of integrals, this is the additivity property. I'm going to do integral from 0 to 7 plus integral from 17 to 20. Integral from 0 to 17, I should have said. So 0 to 17 plus 17 to 20. So these together again, this gives me the area from 0 to 20. But I don't want all that area. I just want the area from 0 to 13. So I'm just going to subtract the area I don't want from 13 to 20, which happens to be this last integral here. And now let me just actually substitute some numbers for these. This first integral was just 8. We're adding negative 3, so actually subtracting 3. And then we're subtracting this last area of 7. So 8 minus 3 is 5, minus another 7 is going to be negative 2, giving me answer choice A. For this problem, I'm given an integral from 1 to 4 of f of x and also for g of x and various values for those. We want to know which of the following cannot be determined from this information. So basically we're looking for an answer that we can't get with the information that we have. So let's look at these one at a time. For part A here, choice A rather, this is integral from 4 to 1 of g of x. Well, we have the integral from 1 to 4, so this is just going to be this other integral basically with the opposite sign. So this is just negative 2, which is positive 2. Long story short, yeah, we can determine this. So this is a no to it being the answer. For this next one, integral from 1 to 4 of 3f of x, this is just going to be the f integral times 3. So 3 times 8 is 24. We can get an answer there. So this is another no. No to not being able to determine it. Double negative. For this one, now we're doing 3f of x times g of x. And it turns out there is no rule for multiplying functions inside integrals. Because you're dealing with areas, I mean, what does it even mean to multiply two areas together? So this cannot be determined, so this is a yes to it being a good candidate for our final answer here. But let's just look at this last answer choice. So this is integral from 1 to 4 of 3f of x plus g of x. Well, we do have an integral rule for adding different functions together as long as they share limits of integration, which f and g do. We can in fact rewrite this as 3 times 8 plus negative 2 or minus 2, which would of course come out to a constant, 22. In any case, we can determine this, so this is a no to being the answer. So then the only one we can't determine is C, so that's what we're picking. On this problem, I have some integrals from 0 to 2 of the f of x function and g of x function, and I want integral from 0 to 2 of 3f of x minus g of x. So I'm going to rewrite this. I'm going to actually split this up using my properties of integrals. I'm going to rewrite my first integral as 3 times the integral from 0 to 2 of f of x. So I can take out that 3 if there's just one other thing inside. And I'm going to be subtracting an integral from 0 to 2 of g of x dx. So this just ends up being 3 times the value of that integral, which they said was 4, minus negative 5. That's the integral of the g of x integral there, or the value of that integral. So this is 12 plus 5, which is 17, giving me answer choice C.